Welcome to Assignment Guide U08280 Term 3 2017. This is Dr. Teo Kim Heng, Informatic Academy. There are two questions in the assignment question paper. The first question is to recognize 7-segment digit display, in short SSD, using artificial neural network on MATLAB platform. The 7 segments of a SSD are arranged as a rectangle of 2 vertical segments on each side, with 1 horizontal segment on the top, middle, and bottom. The segments are numbered as 1, 2, 3, and so on and so forth. When the SSD is used to display digits, some segments are turned on, some segments are turned off. This slide shows the 10th decimal digits and the corresponding 7-bit representation. For example, 1 is represented as 0001100. 2 is represented as 1011011. 3 is represented as 1011110, and so on and so forth. We are going to solve the SSD recognition problem using multi-layer feed-forward neural network. At the input layer, there are 7 neurons corresponding to the 7 bit of the SSD representation. At the output layer, there will be 11 neurons. The number of neurons at the hidden layer is subject to your experiment. The input layer consists of 7 binary neurons: X1, X2, X3, X4, X5, 6, and 7. The activation of the highest neuron is 0, means that the highest segment is off. If the highest segment's activation is 1, it means that the highest segment is on. There will be 2 to the power 7, in other words 128 possible input patterns. There are 11 neurons at the output layer, Y0, Y1 all the way to Y10. Y10 is used to distinguish whether the input is a valid digit or not. If the activation of Y10 is 0, it means that the input is not a valid digit. If the activation of Y10 is 1, it means the input is a valid digit. Other output neurons recognize individual digits. For example, if Y9 activation is 0, it means that the input is not the digit 9. If Y9 equal to 1, it means the input most likely is digit 9. The first step toward neural network training is to prepare the training pattern. Obviously, in this 7-segment display recognition, the 10 valid input must be included inside the training pattern. For all this valid input, the corresponding Y10 at the output layer must be on, because Y10 indicate whether the input is valid or not. For the first pattern, 0, 1, 1, 1, 1, 1, it actually represents digit 0. So Y0 is on, other neuron Y1, Y2 up to Y9 at the output layer will be off. You should verify that these represent the correct training pattern for the 10th valid digit. In order to have meaningful training, we must also feed the neural network with invalid digits. For example, here are 7 invalid inputs, each with only one on segment. Obviously, all these inputs are invalid, therefore Y10 should be all turned off. However, Y0 to Y9 may turn on if the invalid input potential can turn to valid input by turning more segment on. For example, this is an invalid input corresponding to this string. But this potentially can turn to number 2 in this way. Therefore, Y2 is on. It also can be extended to 3 this way. Therefore, Y3 is turned on. However, it definitely is not 0. Therefore, Y0 turn off, Y1 turn off, and Y7 turn off. Here are some invalid input with 2 segments on. For example, the first input has X1, X2 turned on, but the rest turned off. These are all invalid input, but Y0 to Y9 may be turned on if the input can be converted to a valid input by turning more segment on. For example, the first input corresponding to this invalid display. This display can extend to 4 by turning 4 and 5 on. So Y4 is 1. But it's impossible to be Y3 because for Y3, segment 2 must be always off. Therefore, Y3, the activation should be 0. Here are some more patterns with 2 segments on. Most of these segments are invalid. However, look at this pattern 32. It actually represents valid input corresponding to digit 1. Because digit 1 already included previously as a training pattern, so we will delete this training pattern. Other than training pattern, we should design some test pattern in order to check whether the neural network really learned from the training pattern. I suggest to you some valid input as test pattern, and we can check whether the neural network respond according to this output pattern or not. We should also design some invalid pattern and to check whether the Y10 recognize that they are not valid, and other output neuron recognize that whether the input has the potential to extend to a valid input or not. Here, the test patterns are not part of the training pattern. This is to check whether the neural network learn to generalize to the case which was not taught before. Of course, you can also experiment using test pattern which are subset of the training pattern. You should design your own test pattern. If I find any two students having exactly the same test pattern, it will be treated as an evidence of plagiarism, and I will report to the university for discipline action. In this assignment, we are asked to design an experiment with neural network to recognize SSD display. The work involved the following steps: training pattern design, test pattern design, neural network design, neural network training, performance data analysis, and then we fine-tune the training parameter. Hopefully, the neural network perform better in the next iteration. So we retrain the neural network again, analyze the performance data until the performance data is good enough. You are advised to prepare the training pattern this way. First, you create a Excel spreadsheet for the training data. Add a blank column in front of the input pattern and also add a blank column in front of the output pattern. Then you copy the input portion of the training data, including the blank column, from the spreadsheet to a text file, say train input.txt, and save the text file in the current working folder. Similarly, you copy the output portion of the training data, include that blank column from the spreadsheet to a text file, say train output.txt. You save the text file also in the current working folder. We prepare the test pattern similarly. First, we use a spreadsheet to prepare the test pattern. Add a blank column in front of the input portion. Add a blank column in front of the output portion. Copy the input portion to a test input text file. Save it in current working folder. Copy the output portion to test output.txt and save it at the current working folder. Next, we write simple MATLAB command in a M file. A M file is sort of MATLAB program. For example, in this M file p.m, the first line is to clear the variable in the workspace. The second line, load train input.txt, will load from the current working folder this file and save the value in a variable called train input. Next, we transpose train input by using the single quote operator. The reason why we need to transpose the train data and test data is that, well, it is natural to human being to prepare the train data row by row. MATLAB requires us to convert it into column-wise. The train data and test data must be prepared column by column manner. So similarly, we load train output or the target data, transpose it, load the test input data, transpose it, load the test output data, transpose it, and then we launch a GUI tool in neural network toolbox of MATLAB. The command is NN2. Once the train data, test data, and M-file are prepared, we can start our experiment. We first start MATLAB. So you will see the command window, workspace window, command history are all blank. You enter the file name of the M file without the file extension. So remember previously I stored the MATLAB command in the file p.m. So when we enter p, MATLAB will read the command from p.m and execute it. At the end, we will see that we have defined train input, train output, test input, test output, and transpose it properly. You can double click on each of the variables to see the data. Make sure you understand that it is transposed from your input file content. Note that the last command from p.m is NN2, which will launch a GUI for us to design and experiment with neural network. This is the user interface of network and data manager that is launched by NN2 command. For us, we need to click this import button so that we can import the data from command window into network manager. Once we have the train data, test data import into network manager, we can create a new neural network by clicking this new button. When you click import, MATLAB will import the variable from command window into network manager. First, we import train input as input data and click import accordingly. Then you click train output, select target data and click import. Then we select test input, choose input data and click import. Then we select test output and select target data and click import. When we click the new button in the network manager, MATLAB launch a GUI for us to create network or define training and test data. You click the network tab to define the feature of the network. We specify the name of the neural network here. For example, here I specify the name is TEO SSD. We specify the neural network type as feed-forward backpropagation neural network. We must make sure that the performance function is MSE, mean square error, as per the specification in the assignment question paper. The number of layer is 2. It means we need one hidden layer and one output layer. To specify the characteristic of the hidden layer, we choose layer 1 here. The number of neurons at the hidden layer is 5. We can choose the transfer function or activation function for the hidden layer, either tensig or logsig. We specify the train input data set, which has been imported previously. Similarly, we specify the train target data set, which has been previously imported. We can take the default value for the train function and adaptation learning function. To configure the output layer, we specify layer 2. And we do need to specify the number of neurons because the system can determine from the train target file. We can specify the activation function or transfer function, either tensig or logsig. And once we are happy with this design, we can click the create button to create the neural network. Here you will see the train input, test input file that you have imported as input data. You also imported train output and test output as target data. We also define a network called TOSSD. And you can double click on the network. You can define many network, and in this case only one network. You click on the network and the system will launch a GUI for us to start training and testing the neural network. This is the GUI that system launch after you click the neural network. It allows us to train the neural network. It allows us to simulate or test the neural network. It allows us to reinitialize the weight of the neural network. In other words, reset the neural network. It allows us to view the neural network, even edit the weight of the neural network manually. The view gives you the overall architectural view of the whole neural network. The input, the number of neurons determined by the train input data set. And we got one hidden layer, we got one output layer, and it eventually produce the output. To train the neural network, we click the Train tab. We specify the test input and target file. We can click the Training Parameter tab to fine-tune the training parameter value. We can optionally specify the output and error variable name. We click Train Neural Network button to start training. At the end of the training, the system will launch a GUI to show the training state and the performance information. The training state includes Apple, which is the number of iterations that the system had gone through the training data set. Time means the actual time spent for the training. performance means the mean square error that we specify. Gradient means the gradient of the error surface. Mu means the momentum. Validation check means the number of time that validation check end up increase in error. What happened is that the system automatically divide the trained dataset into 3 subsets. The major part is the trained dataset, and another small portion for data validation, another small portion for data testing. So the performance is based on the test data. However, the validation data is used to validate the training. So after each iteration, the system check whether the neural network learn to generalize by running the validation data. If by running the validation data, the neural network end up more error, it means that maybe the neural network is overlearned. And so much so that it actually cannot generalize to the validation, which are the unseen portion of the data. So in this case, the system will stop the training. To see the performance, training state, and regression information visually, we click the 3 corresponding buttons here. This slide shows the performance information, state information, and regression information visually. The most interesting part is the performance information. Here the x-axis shows the Apple and the y-axis shows the performance measure, meaning mean square error. Remember, we separate the data into 3 sets: train data, validation data, and the test data. Well, for the train data, the error must be always decreasing as expected. However, for validation, because we are running it on data that neural network never see, it may end up increasing the error. So you will see that for the green line, which is the validation, the error going down, eventually going up. And the best, in terms of best point to stop is at Apple number 3. The red line is for the test data. The green and red line is more or less perform in a similar way. It can be going up and going down. If it's overtrained, then the error for the test data and the validation data will go up. And if it's not yet fully trained, the error for the validation data and the test data will going down. We can run our test data by clicking the simulation tab and specify our test input. Optionally, we can enter our test target. Optionally, we can specify our output and error variable name, and then we can run the simulation. And the output data compare with our test output you can measure the error. We can export the neural network that we created and the output together with error data that we collected from the experiment inside Network Data Manager to MATLAB desktop so that we can perform detailed analysis. To do so, we click this export button. We can select the object from the Data Network Manager and export it to MATLAB desktop. When you go back to MATLAB desktop, you will see inside the workspace all the variable that export from Data Manager, from the GUI. In particular, we see the error file, and double click on the error file will give you the information. You can export all this information into Excel and perform detailed data analysis in Excel. For example, we can compare our test target data with the network output data and compute the difference so that we can compute our own SSE, sum square error. We can fine-tune training parameter in the GUI NN2 Network Data Manager under this training parameter tab. For example, we can specify the minimum gradient to be maybe rather than this one is 0.01, you can specify the minimum gradient is 0.001, make it smaller, much smaller. And then you may want to enhance the apple to be 10,000 and so on and so forth. The assignment question paper asks us to change the learning rate and see the effect. Unfortunately, we cannot change the learning rate through the GUI NN2. We need to do it within the command window. In order to do so, we export the neural network, in this case TOSST. It will enter TOSSE in the command window. You will see the information of TOSST object as a neural network. You should study the property. You should also study practical aid for the command to train and change training parameter in command window. This portion will leave it to you for experiment. This is the end of the assignment guide. Thank you for your attention.